Rate law. Rate law is simply a mathematical expression that is used to describe how the reaction rate depends on the concentration of the reactant. So it is just an expression that shows you the relationship between the speed of a reaction and the concentration of your reactants. The general rate law, for example, if this is my reaction, AA plus BB gives you CC plus DD, the general rate law is rate equals K, concentration of A to the power of M, concentration of B to the power of N. In the case of rate law, what's included is only the reactants. We do not include products because, again, the speed of reaction does not depend on the product concentration. It only depends on the concentration of the reactants. Next important thing to remember here is these numbers that you see in the power M and power N. These have nothing to do with the stoichiometric coefficients. Okay, these coefficients are only used in the rate expression, what we saw earlier. If you did not see this part, the video before this, then please watch that part. That part tells you rate is equal to negative concentration of A over time divided by A. This is where this type of expression is where we use the stoichiometric coefficient. But when we are writing the rate law, the coefficient does not play a role. Okay, most of the times these numbers are different from the stoichiometric coefficient. They can be same. M can be equal to A, but it's not necessary. How do we find what is M and N? First thing, what are these? Let's just look at that. What is rate here? Rate here is speed of the reaction. What is K here? K is called the rate constant. It's a constant term. It only changes when you change the temperature. It does not change if you change concentration. It does not depend on anything but temperature. The value of K only depends on temperature. Another thing is the value of K can only be determined experimentally. So we can't figure it out just by numbers. You need to do an experiment to find what is K. Similarly, concentration of A and concentration of B just means concentrations. What are M and N? M here and N are called the reaction orders. M is the reaction order for A, N is the reaction order for B. These are called the order of the reaction. Order just means by what order does the rate depend on the concentration of A. Okay, so that's order of the reaction. Remember, these do not have to be equal to the stoichiometric coefficient. So this is the reaction order. In general, rate is always going to be equal to K, concentration of your reactant to the power of M or N or whatever. Okay, and this M can have multiple values. It can be equal to 0, it can be equal to 1, it can be equal to 2. Does not matter. What does this mean? Again, this is just a word that we are using. So it can be M, it can be N, like shown here. Remember, what is this? This is the order of the reaction. So reaction order with respect to M and with respect to A. When M or N is equal to 0, that means reaction is 0 order with respect to A, which means rate is equal to K, A to the power of 0. Anything to the power of 0 is 1, which means rate is equal to K times 1, which means rate does not depend on concentration of A. That is called 0 order. 0 order means it does not depend on concentration of A. You can change concentration of A as much as you want. Your rate will not change. The next is if N is equal to 1, that is first order reaction, which means rate is equal to K, A to the power of 1. A to the power of 1 means if I double the concentration of A, let's say I double this, instead of A I make it 2A, what will happen to my rate? My new rate will be K times 2A, which means it will be 2K, which means my rate has also doubled in comparison to previous one. So if this was my rate 1, this is equal to 2 times rate 1. So my second rate is twice the rate 1, which means this is first order reaction. When you double A, your rate also doubles. When you will triple your A, your rate will also triple. Then n is equal to 2 is called the second order reaction. Second order just means that rate is equal to rate 1, let's say k times a to the power of 2. Whatever your power is your order. Okay, so if this is 2, which means let's say I double the rate, double the concentration of A. So what will happen to my rate? My new rate will be 2A squared, which means it is 2 squared times K times A, right? Which means I can say it's 4Ka. And what was Ka squared? Sorry, what was Ka squared? Ka squared is rate 1, which means it is equal to 4 times the rate 1. So my rate is 4 times. When you double the A, your rate became 4 times. That means it's a factor of squared. So your n is now 2. Okay, so another thing that I want to mention here is, for example, if my rate is dependent on two reactant, it is K a to the power of m and b to the power of n. M is rate with respect to A, n is let me repeat that. M is order of the reaction with respect to A, n is order of the reaction with respect to B, and m plus n is the overall order of the reaction. Okay, so when a reaction has multiple reactants, each reactant has its own order, and the overall reaction order is sum of the orders with respect to each reactant. So m plus n is overall order of the reaction. And a lot of times the question will simply ask you, can you write the rate law for this equation? That's what you need to write. Which is rate is equal to K, whatever reactant you have. If you have 4 reactants, you write 4 reactants and they're multiplied by each other. There's nothing here, which means it's a multiplication. A to the power of m multiplied by b to the power of n. So this is just explaining what I just explained. It's written in words. In zero order, changing the concentration of reactant has no effect on rate of the reaction, and we saw why, because it's Ka to the power of 0, which means your rate does not depend on A. This does not exist. In a first order reaction, n is 1. Rate law is rate is equal to Ka to the power of 1. If A is doubled, the reaction rate also doubles. Why? Because you make this 2A, everything becomes 2Ka, right? When A drops to 1/2, the rate will also become 1/2. So if I make this A divided by 2, which means I made this half, which means everything will become half. In a second order reaction with a single reactant, n is equal to 2, Ka2, when concentration of A is doubled, the rate will quadruple. Why? Because it's K2A squared, which means it's 4Ka squared. So initially it was Ka squared, now it is 4Ka squared. So your reaction rate quadruples. If I triple the concentration of A, my reaction rate would become 3 squared. Why? Because n is equal to 2. So whatever change you make to A, if A is squared, then the factor would also be squared. If A is tripled, then factor would also get to the power of 3. If A drops to 1/2, the initial concentration, the rate will become 1/4, because it's a power of 2. So whatever change you're making, it will become that change to the power of that order. These are the two graphs that are showing you that same thing. So for example, in the first one, this is concentration versus time. So this is concentration of A. So here you can see the concentration of A. In this first plot, the concentration of A is not changing over time, which means zero order. In the second one, this is the concentration change. It's changing slightly as the time passes. And in case of B, in this last one, the concentration is changing a lot faster. which means this tells you this is a second order because it depends on that concentration a lot more. The next plot that you see here is a graph between rate, which is the speed of the reaction, over concentration. So when you change the concentration, if your rate changes, then it is dependent on that concentration. For example, in case of zero order, you can keep changing the A, but your rate, this is the speed of the reaction, right? So if this is the speed of the reaction initially, I change concentration of A. Over time, I made it double, I made it triple, I made it 4 times, 5 times, but the sorry about that, I am doubling or tripling my concentration of A, but my rate, speed is not changing, which means it's a zero order reaction. So just by looking at the graph of your data, you can figure out what's your rate law. If I increase the concentration of A and the rate also linearly increases with it, that means it's to the power of 1. It's a first order reaction. If I am increasing the concentration of A and the rate is increasing, but it's increasing exponentially like this, that means it's a second order reaction. Okay, in our case, in this syllabus, we are only going to focus on these 3 orders: zero order, first order, and second order. It can be higher than that, but we are only going to be restricting ourselves to these 3 orders. Now, starting here, I'll be going over a lot of examples with you, so you guys can try these examples on your own and come back to the video whenever you feel stuck. Okay, so for example, for the reaction 2NO plus 2H2 gives N2 plus 2 water, the rate law is this, which means with respect to NO, it is second order. With respect to hydrogen, it is first order. There's nothing written, that means it's a 1. Overall order of the reaction is, overall order means M plus N, so it is 2 plus 1. Overall order is 3. That's exactly how some questions would be. Okay, now remember, so you can see here this is 2 and this is 2, which is great, but in this case the coefficient of hydrogen is 2, whereas the power here is 1. So remember, these numbers that are the order of the reaction do not have to match with the coefficients. Okay, and how do we determine these? These must be determined from experimental data. They cannot be deduced from the balanced equation. There is no other way. If you want to know the order of reaction, it has to be done experimentally. Okay, for example, for each of the following reactions, use the following rate law to determine the reaction order with respect to each reactant and overall order. Okay, so for in this case, what is this? This is 2, this is 1, and if I say overall is 2 plus 1, 3. For this reaction, because it tells you this is the rate law, it means with respect to CH3CHO, it is 3 by 2, and overall is also 3 by 2. You cannot make any changes to this. It is what the rate law tells you. For this part C, H2O2 is 1, I is 1, and overall it is 1 plus 1, which is 2. You do not have to even look at the equation. You don't care what the phases are. It can be gas, liquid, aqueous, it doesn't matter. It can be 1, 2, 3, whatever the coefficient. What matters is just the rate law. You just focus on this. Whatever you see on top, the numbers, those are your numbers. That is it. Okay, so we finished part A of the question, which was determine the reaction order with respect to each reactant now and the overall order. Now let's focus on the second part, which starts here. For the reaction in A, determine the factor by which rate changes if NO is tripled and O2 is doubled, which means I need to find what is the new factor, okay, by which if NO is tripled, so NO becomes 3NO and it is 3NO squared, and oxygen is doubled, which means it is now 2 times, so it is 2O2 doubled, and the factor is 1, so this is all okay, and this is my new rate. Okay, so what happened here? K is same between the two, so I can ignore it. NO square is same between the two, so I can ignore it. What's left is 3 squared. 3 square means 9. So it is 9NO squared times 2 to the power of 1, which is 2 times O2. And K is same, and this is my new rate, right? So rate 2 is equal to this, which means this and this is same, this and this is same, this and this is same. So what is my new rate? New rate is basically 9 times 2, 18 times of what it was before. And that's it. You don't even have to write it if you understand this well. You triple the concentration of NO, so it's 3 squared, which is 9 times. Oxygen is double, so it is 2 times, so 9 times 2 is 18. Let's try another one. Example 4. The rate law for this reaction is given to you. A squared and B to the power of 1. At certain concentration of A and B, the reaction has initial rate of this. Calculate the new initial rate when concentration of A is doubled and concentration of B is tripled. So A gets doubled, which means it becomes 2A squared. And B is tripled, which means it becomes 3B to the power of 1. So what is the factor here? It is 2 squared times 3. Because A square is same here, A square, and B1 is same. So the factors, we only care about these. So it's 2 squared, which is 4 times 3, which is 12. So your rate would become 12 times 0.220 molar per second. And that's it. You can see here 12 times of this. You can do this like how it is shown here. Write the older rate, write the new rate, divide the two, take the ratio, and that gives you 12. Or you can just do this in your head like we just did. Let's try one more. If the reaction rate has a rate law of this, by what factor will the rate increase if A is doubled? So A is 2A, and carry the factor, okay? Carry the reaction order. And B is tripled, so it's 3B squared, which means A square and B square, I know will cancel out, same here. So it's 2 squared times 3 squared. 2 squared is 4 times 9, so that would give you 36. So my answer here is 36 times. Now this is a second type of question you can get here. In this case, the concentrations are given to you and the rate is given to you, but the question is asking what is the order. So this is like reverse of what we did so far. Determine the reaction order and the value of rate constant for decomposition of nitrogen dioxide from the following data collected. So if this is my reaction, question is asking what is the reaction order A, and it's asking what is the decay constant. Reaction order we know is like value of M or N, whatever you want to call it. And rate constant means I need to solve for K. What do I know from here? I know that rate is equal to K NO2 to the power of M. So I need to find what is M. How can you find this? In this data, first thing, understand what the data is. This data is experimental data which gives you initial rate at different concentrations of NO2. So in experiment 1, NO2 was 0.075 and the rate was 3.04 times 10 raised to power minus 6. In experiment 2, we changed the concentration of NO2 and measured the rate again. In experiment 3, we changed the concentration again and we measured the new rate again. So now if I need to solve for M, the best way to solve this is you pick any two experiments you want. Okay, if you can do this in your head, great. If you cannot do this in your head, the other way is we will follow the long route, which is you find the ratio between two experiments rate. Okay, for example, I know this is my general expression. Rate is equal to K NO2 to the power of M. I can find this ratio for 1 or 2 or 3, whichever one, any two experiments. Okay, let's say I do this for 2 and 3. Why? Because it's easier. I can see this is 0.01, this is 0.02, so it's twice. Okay, so rate of 3 divided by rate of 2. You can also do reverse, it doesn't matter. Okay, equals to what? K NO2, because this is 3, this would be reaction 3 to the power of m. K NO2 to the power of 2, because this is reaction 2. Now from here I know K and K are same, so they'll cancel out, which means I can plug in the values now. What is rate for 3? It is 2.15 times 10 raised to power minus 4 divided by 5.40 times 10 raised to power minus 5 equals NO2 for 3 was 0.02 to the power of m divided by 0.010 to the power of m. If we plug this into our calculator, let's see what does it give us. It gives us 3.98, okay, which I can assume is same as 4. So this solves for 4 equals, if we plug this into calculator, 0.020 divided by 0.10, that would give you 2 to the power of m, which means 4 is equal to 2 to the power of m, which means what should be my m? M should be 2, and that's it, you're done. That just means I solved what is my m, which means I can say rate is equal to K NO2 to the power of 2. That is my new rate law. Okay, another thing is, now the question was part B, was asking what is your rate constant, means I need to solve for K. How do I solve for K? Now that I know my power is 2, you can pick any example from here, whichever one you want, 1, 2, 3, all of them will give you the same answer. Let's say we pick experiment number 2. Experiment number 2 rate is, and plug in the values, plug all the values from experiment 2 in this expression. 5.40 times 10 raised to power minus 5 equals K 0.010 to the power of 2, which means K is 5.40 times 10 raised to power minus 5 divided by 0.010 squared, and you solve for this and that would give you your K, molar inverse, second inverse. Okay, so include the units. This is molar per second, it's given to you, m per second. This is m, so it's molar per second divided by mole squared, right? M squared, which means this and one of these would cancel, which means it becomes m inverse, second inverse. Units of K are very important, and we'll see shortly, because just by looking at unit of K you can tell what is the order of this reaction. Okay, so question could be like this. So here, once we have solved for K, we are done with the question. Part A is done, part B is done. This is the same exact approach that you can use to solve every single question. There is no other way the question can be worded. There is no other way, another type of question. It would always be some experimental data will be given to you. You just have to compare any two experiments that you want and find the order first, and then if the question is asking, find the decay constant. This is the type of question where we only had one reactant in the expression. Rate is only dependent on the concentration of one of the reactants. You could also get questions where the rate might be dependent on two or more than two reactants, for example like this. How do we do a question like this? Again, the experimental data will be given to you. In this case, for example, there's 4 experiments that were done. These are the initial rates for each. This is the initial concentration for A, and these are the initial concentration of B's. Okay, same question, you have to solve for M and N. Again, there's only one type of question like this. Okay, there is no other way this question can be given, and there is no other approach to solve a question like this. So I'll show you what is the approach, and you just follow that same approach for every single time. This approach is similar to what we did in the previous question. In that case, you had only one reactant. Here we have 2, but we have to reduce this rate constant to only one reactant at a time. How would we do that? We will find the 2 experiments out of this data that is given to you, we will find 2 experiments where only A is changing, and we'll find the 2 experiments where only B is changing, and we will use those experiments. Okay, what does that mean? For example, if I'm interested in solving for M, let's say we can only focus on one number at a time, either M or N. If I'm interested in solving for M, I will choose the experiments where I can cancel B out. So I will choose the experiments where B is constant. For example, let's see here. Are there any 2 experiments where concentration of B is constant? Experiment number 1, experiment number 2. So if I'm solving for M, I will choose the experiments 1 and 2, and I will calculate the ratio between the two, just how we did previously. Okay, if I'm interested, now let's say I've solved for M, now I want to solve for N. If I want to solve for N, I want to get rid of A, so I will choose the experiments where A is constant. So for example, experiment number 1 and experiment number 3, here A is constant, A is not changing. Okay, so I will choose these 2 experiments when I'm solving for N. So that's how you do this experiment. Or you can choose experiment number 2 and experiment number 4, same thing. In this case also, these 2 are constant, but B is changing. So you have to choose an experiment where A is not changing but B is, or you have to choose the experiments where B is not changing and A is, if you're solving for A. Okay, so whatever you're solving for should be changing, and the other guy should not change. Okay, so let's try this question. We'll use the same approach. Okay, we'll find 2 experiments, we'll compare their rates. So this is my rate law. So let's say I'm focusing only on A for now. I want to solve what is my M. So I need to find experiments where B can be cancelled. Those experiments where A is changing and B is cancelled. Experiment 1 and experiment 2. Sometimes you might be able to do these experiments in your head as well. Okay, so let's see. In this case, B is not changing, which means I can ignore B, right? What is happening to A? A concentration is changing from 2.5 times 10 raised to the power minus 2 to 5.0 times 10 raised to the power minus 2. What happened to A? A became doubled, right? 2.5 became 5, which means A was doubled. Now let's look at rate. What happened to rate? Rate went 1.75 times 2 times 10 raised to the power minus 3 to 3.5 times 10 raised to the power minus 3. If you find what is the relationship between these two, you just take 3.5 divided by 1.75, you will find that what happened to the rate is also doubled. So if you take 3.5 divided by 1.75, rate also got doubled, which means when you double the A, rate also became doubled. So when rate became 2 times equals K, A also became 2 times to the power of M, which means this was 2 equals 2 to the power M. So what is my M? 1. So you can do this in your head as well. In this case, M is 1. Okay, if that was too fast, we can use the approach that we used earlier, which is rate of 2 divided by rate of 1 equals K A to the power of M of 2 divided by K A to the power of M of 1. Plug in the values. Rate of 2 is, let me clean this out a little bit. Rate of 2, I'll solve it right here. First thing, K and K will get cancelled. Rate of 2 is what? 3.50, need more space, let's do it here. 3.50 times 10 raised to the minus 3 divided by 1.75 times 10 raised to the minus 3. Okay, equals A of 2. A of 2 is 5.00 times 10 raised to the minus 2 to the power of M divided by 2.50 times 10 raised to the minus 2 to the power of M. If you solve for this, this will come out to be 2. If you solve for this, all of this, 5 divided by 2.5, that will also come out to be 2 to the power of M. When I put this over this M, that means I'm basically saying all of this to the power of M. Does that make sense? So I can say this, right? Which means I can say 2 is equal to 2 to the power of m. So what is m? 1. So you can use this approach as well. Okay, that was me solving for m. Now let's say I move to second part where I need to solve for n. Now if I'm solving for n, I will choose the experiment where a can get cancelled. There is no m left. So I will choose experiments where a is same but b is changing. So a is same, meaning experiment number 1 and experiment number 3. Let's choose this. So again, try and do this in your heads first. So b is becoming 3 times 10 raised to the minus 2. Pay attention to the powers as well, okay? 6.00 times 10 raised to the minus 2. It became 2 times. What happened to rate? Rate bent from 1.75 times 10 raised to the minus 3, 3.5 times 10 raised to the minus 3. Also 2 times, which again, what is my n? N is also 1. Okay, 2 times became 2 times. Okay, or you can again write it down. For example, I'll take a rate of 3 divided by rate of 1. You can do reverse as well. 1 over 3 doesn't matter. It would not make a difference. K b to the power of 3 to the power of n. K b of 1 to the power of n. K and k cancelled. Let's plug in our numbers. Rate of 3 is 3.50 times 10 raised to the minus 3 divided by 1.75 times 10 raised to the minus 3 equals 6.00 times 10 raised to the minus 2, which is for 3, to the power of n divided by 3.00 times 10 raised to the minus 2 to the power of n. Again, if you solve this in your calculator, it will come out to 2. If you plug this, remember, we can reduce this to what? 6.00 times 10 raised to the minus 2 divided by 3.00 times 10 raised to the minus 2, everything to the power of n. Okay, because both are to the power of n. If you solve this, this will come out to be 2. So 2 is equal to 2 to the power of n, which means n is 1. So we have solved for this. That means, what is my rate law? Rate equals k a to the power of 1 times b to the power of 1. So that's my rate law. Now there could be a third part to this question where they ask you, what is k for this? How do you solve k? Pick any one of these 4 reactions. For example, I'll pick 1. So that's my rate, goes here. That's my a, goes here. That's my b, goes here. I would rearrange and solve for k. K will be rate divided by a to the power of 1 divided by b to the power of 1. Plug all these numbers here and you have solved for your k. And that's it. So there is no other approach. Remember, this is the only approach to solve the questions. Find 2 reactions. If you can do this in your head, great. If you practice it more, you will be able to solve these questions in your head, as long as the numbers are multiples of each other, right? If they're not, you have to use a calculator. Okay, no shortcut. So we can try maybe another question, and there are a lot more examples in this slide, so you can keep working on it. Many gaseous reactions occur in car engines and exhaust systems. One of these is this. Rate is equal to K NO2M CO N. These are the 3 experiments given to you. Use the following data to determine individual and overall reaction order. So 3 experiments are given. Again, I have 2 reactants, so I will choose 1 reactant at a time. Let's just focus on NO2 for a second. And you can see the numbers here. The numbers look a little bit manageable, right? So they are like multiples of each other. So we'll try to solve this without using without writing it out. So NO2 to the power of m. So I want a reaction where CO is constant. Okay, so CO is right here. 2 reactions where CO is constant is 1 and 2. These are not changing. but these are, so I'll choose 1 and 2. What happened to NO2 concentration? 0.1 to 0.4, 4 times. What happened to in rate? 0.005 to 0.08. If you can't do this in your head, that's totally okay. Use a calculator. 0.08 divided by 0.005. Plug this into your calculator and you can solve this. Okay, if you plug this in calculator, you will see this comes out to 16. So this became 16 times. Okay, which means when your rate became, when your concentration changed 4 times, this was 4. Concentration is always to the power of n, right? This is concentration to the power of m. So 4 to the power of m is equal to 16, which means what is my m? M is 2. Okay, always remember, you take your concentration. Concentration is to the power of m, and rate is basically just rate, ratio of rate. If you did experiment number 2 divided by experiment number 1, that's how I got 4, right? I got 0.4 divided by 0.1. That is why I'm doing 0.08 divided by 0.005 and not reverse. Remember that when, if you're trying to do this in your head. Okay, again, if you're trying to do this in your head, remember, I'll just rewrite this part one more time quickly. I'm choosing 2 experiments. You can write it down, it will give you the same exact answer. Okay, I know this will not be there and I know K will not be there, so only difference is rate is equal to this over rate equals this, right? So 2 rates. So your choice, you want to do 1 over 2 or 2 over 1. I like to do 2 over 1 because I can see this is a bigger number, right? So if I do 0.40 divided by 0.10 to the power of m equals rate of 2, which is 0.080 divided by 0.0050. That's it. If you plug this in, you will find 4 to the power of m. If you plug this into your calculator, you will find it as 16. So 4m equals 16 means m is 2, and that's it. Okay, now let's do the next part. We have figured out m. Now I need to find what is n. If I'm solving for n, I will choose experiment where this is constant. So NO2 is same. NO2 is same in experiment number 1 and experiment number 3. So I will choose these 3 experiments. CO is changing. Again, I like to go higher over lower. Okay, so that would be rate of 2 divided by 1. So that would be 0.20 to the power of n divided by 0.10 to the power of n equals 2, which is 0.005 divided by 0.005. So this became 2 times, but this is 1 times, so it is same. So 1, and this is 2. So 1 is equal to 2 to the power of n, which means what is n? 0. Which means you're changing the concentration, but the rate is not changing, which means it is a 0 order reaction, and that's it. I took longer because I'm explaining it, but you can do this within like a minute or 2 minutes. Okay, so what is my rate law? Rate is equal to K NO2 squared times CO to the power of 0. Or if it is 0, you don't even have to include this. You can simply say rate is equal to K NO2 squared, and that's it. You don't even include this because we know CO to the power of 0 is 1. Your choice. Okay, next question is calculate overall order. Sorry, we forgot. What is the overall order? 2 plus 0. Overall order is 2 plus 0, which is 2. Next is calculate K using the data from experiment number 1. It's telling you experiment 1. If it didn't, choose whichever one you want. Experiment 1 means this is my rate law, so I have to solve for K. What is K? K is rate divided by, let me write it better. K is equal to rate divided by NO2 squared. So experiment number 1, this is my rate, put that in. This is my concentration, put that in, squared, and I don't care about CO because it's not in my expression. And that's it, and you're done. Solve for this. So it's all done here. Repeat it. M is equal to 2. For CO, N is equal to 0, 0 order. This is my rate law. Overall order, it says second order, and then you take experiment 1, plug it in. K is 0.5. Okay, mole inverse, second inverse. You can write the unit like this, mole per liter, or you can write 0.50 mole inverse, second inverse. That would also do. Okay, there are more questions. I will let you guys try these out on your own, and then you can match the answers, okay, and see if it works out. In the slides, again, they are listed like everything's written word by word, but again, you do not have to write. You already know these will cancel out, right? So you do not have to write them, but this is just written in details. And the only way, the best way to do these questions is practice, and this is the only approach that you use. More questions, so please practice these questions on your own. Okay, now the next part is the units. How can you use the unit to find the order of the reaction? Okay, the unit is easy. Okay, just how you cancel numbers, you can cancel units. What do I know about rate? Rate is equal to K A to the power of M. And what is M? Order of the reaction. So if M is 0, that means what is rate? Rate is, what is a unit of rate? Molar per second, right? Molar per second, that's the unit. Concentration over time equals K. And what is the unit for A? A is concentration, so it would be molarity to the power of 0. Molarity to the power of 0 means it's 1, which means this is equal to K. So what is K? K is molarity over second. Molar per mole per liter over second, or mole per liter over second, whichever way you want to write it. Molar, mole per second. Okay, the next is if the overall order is 1. So let's do that. If the overall order is 1, that means M per S. Rate will always be M per S, nothing else. S, if its time is S, then it's S. It could be hour, minutes, whatever, but it would always be molarity over seconds. This is equal to M to the power of 1, which means what is K? So if I rearrange this equation, this is my expression. If I rearrange it to solve for K, if I'm solving for K, I need to isolate K, which means I need to get rid of this M. So I divide this by M, which means I should divide this side also by M, which means what is K? K is equal to only second inverse. So that's the unit if it's first order. Okay. Similarly, you can do whatever unit you want. If let's say I'm focusing on second order, rate is molar per second equals K. Second order means molarity. A is M, molar, and M is 2, small m, so squared. So I'm solving for K, which means I need to isolate K. So I need to get rid of M square. So I'll divide this by M square. This will get cancelled. So I also divide this by M square, which means 1M and 1M gets cancelled. So what is K? From here, K is 1 over M second, which is same as molar inverse second inverse, which is basically this unit that you see. Okay, or you can write molar inverse second inverse. Okay, so that's how you solve for unit. Example 3. 3 simply means rate is molar per second equals K molar cube, molarity cubed. Okay, now again, to get rid of this, I divide this by the cube of M. I divide this by cube of M. This would get cancelled and it would be left with 2, which means what is my K? K is 1 over M square times second. You can write like this, or you can write it as molar minus 2 second minus 1, which is also written like this. Only difference here is they have expanded molarity. Molarity is moles per liter. So instead of this, I could write moles per liter. What are the units of K for the following rate law? I'm only interested in units, so I'll just work with units. Rate is molar per second equals K. A means concentration of A means molarity to the power of 1, and B means molarity to the power of 3. So again, that means I can say molar per second equals K m to the power of 4. I'm solving for K, so I need to isolate this, which means I should get rid of m4. So I'll divide this by m to the power of 4. That cancels this out, which means I'm also going to divide this side by m to the power of 4, which cancels one of these. So the unit that I'm left with is K equals 1 over m cube second, which is same as -3 s to the power -1. So your answer is D. So this is a summary of whatever we saw for now. Order of the reaction. So if it is 0, first, second, third order reactions, it could be written in any of these formats. Rate is K a to the power 0. This is the unit of K. Rate is K a to the power 1. This is the unit of K. Rate, if it is second order, it could be K a to the power 2, or it could be two reactants each to the power of 1. Overall order in both the cases will be 2. Okay, and this is the third order reaction. And that's basically order of reactions and rate laws.